Hello. So today we're going to look at similar triangles. So similar triangles are triangles that are pretty close to looking the same. They are similar, so to speak. Yes, that may seem kind of funny, but in essence, that's really what it is. But the way we say that triangles are similar is based on their angle measurements. If they have congruent angles, then they are similar. If they have congruent sides, then they are going to definitely be congruent. So what does that mean then? Is there a difference between the two? Well, yes. Every congruent triangles are similar, but it's not true going the other way. For example, if these two triangles have the same angle measurements, which I can say they do, but obviously one is much larger than the other, right? Well, they're similar. And because they're similar, I can then find out things about one side and one triangle and know automatically things about the other because I know they're similar. Now, when two triangles are said to be similar, there is a proportion in regards to their side lengths. And that proportion is because of their angles being the same measurements. So, this is just kind of to generally get you set up understanding the difference between similar triangles and congruent triangles. So, let's make these maybe a little larger, make them look the same size, but they won't actually be, to better understand similar triangles. So if I'm going to draw two triangles and I'm going to tell you they're similar, okay, these two triangles here are similar. Well, I want to tell you then that the measurement of this triangle is 30 degrees. I'll tell you that this one is 71 degrees. And I'll tell you that this one is 30 degrees as well. And I will tell you then that this one is 79 degrees. Okay. Well, the question is, are these two triangles similar? In order for two triangles to be similar, their angle measurements must be congruent. Well, we see that this has a 30 and this has a 30, so we're at least good there, right? But we don't know about this angle or this one. But that's okay, because we do know that the sum of the angles in a triangle has to equal 180 degrees. Therefore, we can find out what these two angles are based off of that. Well, we know that if we take 30 plus 71, we'll get 101. And from 101 to get to 180, we need 79 more degrees. So this must be 79 degrees. Well, that's what that is there. But just to be sure, 79 plus 30 equals 109. That means we need 71 more degrees in order to get to 180. Well, 30, 30, 71, 71, 79, and 79. These two triangles are now similar. Well, if they're similar, that means their angles have to be congruent. Well, we see that they are. We have 71 with 71, we have 30 with 30, and then we have 79 with 79. Okay. Now, I won't always do the arcs to show that they're congruent. I think the numbers are enough to show that they're congruent, but just so that you get used to the idea. But anyway, we see that these are now similar. Well, because of that, I also know something else. If, for instance, this side is 2, and let's say this is 4 and this is 5. Now, do note that I am not saying that this is the triangle and its angle measurements. I just completely made up those numbers. They could be or could not be correct. I just want to put that as a caveat for later when you're like, hey, remember that time you did that and that doesn't make sense? It's okay. This is just for clarity and understanding. So, from the 30 then over here, I'm going to say instead that this one over here is a measurement of 6, and that this is going to be a measurement of 15. Well, what's this one going to have to be? Well, I said they were similar, right? Meaning their angles are congruent in measurement, but there should be a similarity with their side measurements as well. Well, what's the similarity? Well, let's take a look. We see that we go from 2 to 6 for the side length that's opposite of the 30 degrees. We see that we go from 5 to 15 for the side length that's opposite of the 79 degrees. Do you see a relationship between those two? Going from 2 to 6 and then going from 5 to 15, many of you may say, I definitely see a relationship. But some of you may say, no, I don't see a relationship. Well, let's see if we can find one. The thing is that there is a direct relationship or direct proportion between the measurement of an angle and its opposite side that we've talked about several times. But because there's a direct relationship, that means there must be a proportionality constant among this as well. So to find that proportionality constant, there's two things that you can do. Well, we can take these two measurements here, 6 and 3, and divide them. And then we see that going from this one, going from the smaller one to the larger one, that's a 2. We see that going from the large one to the small one, or small to the large, there's this constant of a 3. Well, let's see if that holds true for the 15 and 5. When I do 15 divided by 5, I still see that same proportionality constant of 3. Therefore, if we take any of these sides and multiply by 3, we will get the other triangle. That's the proportionality constant that we see for these two similar triangles. You will always, if you know that two triangles are similar, there is always a proportionality constant between them. Know that, hey, they're directly proportional, meaning as one increases, the other has to increase by the same factor. So to find it, we can divide our two corresponding sides, corresponding meaning that they're opposite of the same angles, to find the proportionality constant. It should be the same for all of them. If it's not, then your triangle is not actually similar. All right, so very important things to keep in mind. Well, let's use this then to find out what x has to be. We know that whenever we take something from this first triangle, multiply times 3, we get the second one. So we need to find the corresponding side for x. Well, x is opposite of 71 degrees. 4 is opposite of 71 degrees. So therefore, x must be equal to 3 times 4, or x has to be 12. It's that plain and that simple. That's how we can find out sides if we know the proportionality constant and we know that two triangles are similar. So x has to be 12 in this instance. That's kind of cool, right? Yeah. Well, let's leave it there for now, and we'll look at some other similar triangle examples in a few. I'll see you soon.